Assalamu alaikum. This is our lecture number 41 of Managerial Economics, and the topic that we are going to discuss is risk analysis. Actually, we have started this topic in our previous lecture. Let me give you a brief review of the previous lecture before we start today's lecture. In our previous lecture, we have seen that we have introduced three basic terms regarding the risk analysis, that is certainty, uncertainty, and risk. In order to make effective decision making regarding long-term investment decision making, the manager, they have to understand many phases of risk. That is, they have to understand different levels of risk which are involved in these different projects. Now, first of all, we have said that as far as certainty is concerned, we have seen for each possible decision there is a single outcome, so that the manager is sure or certain about the return on that project. In case of risk, we have defined it as a situation where there are more than one outcomes to each decisions. As a result, different probabilities are assigned to these outcomes. If the probabilities are known, the probabilities are assigned to respective outcomes. If, on the other hand, these probabilities are not known, these probabilities can be estimated. In case of uncertainty, it's not just that there are more than one outcomes of a single or one decision. There are more than one outcomes of a single decision, but also the problem here is that the probabilities, either they cannot be assigned or they cannot be estimated, or even if they are estimated, they are not meaningful. Now, why these probabilities are not meaningful? There could be various reasons for it. One of the most important reason is that it is important. It is quite possible that the past data is not complete, or it is not correct, because in order to measure risk, there are two approaches to estimate probabilities of outcomes of business decisions. One is a priori probability approach, and the second is a statistical probability approach. In the first case, if we toss a coin, there are two possible outcomes, that is a head or a tail. So we say that there is a probability of 1/2 of the appearance of a head, and probability is the same for the occurrence of a tail, because there are only two possible outcomes. लेकिन अगर हम इस coin को, let's say we toss it for more than one times, that is 5 times, and it's quite possible that the result that we get is that 4 times a head occurs and only one time a tail occurs. What does this indicate? Previously we have said that in a single throw of a coin, and we assume that the coin is balanced, उसमें हमने कहा that there is a 50-50 chance of a head or a tail. But now we are saying that there is 4/5, which means that 80% chance that a head will occur, and there is only 20% chance that a tail will occur. But if we now repeat this experiment or this event for an infinite number of times, ultimately we'll notice that this will be close to a 50-50 chance. So this is about the first type of probability. The second type of probability, where we calculate, where we use statistical probability. In that case, it is assumed that इस केस में ये जो probability हम जब statistical use करेंगे, तो यहाँ पे assumption ये है कि probability of an event in the past will hold also in the future. And in order to measure this probability, in order to measure risk in this case, we made use of the absolute measure of dispersion, and also we have also made the use of relative measure of dispersion. That is, या हम standard deviation use करेंगे या फिर coefficient of variation use करेंगे. So इस तरह से हमने ये तीनों terms जो थी define की हैं, और इसके बाद next we have considered how to measure risk. And for that purpose, first of all, we have introduced probability distribution, and then we have introduced the concept of expected return or expected profits, because we are considering here long-term investment decisions. सो एक्सपेक्टेड प्रॉफिट जो थे या एक्सपेक्टेड रिटर्न वो हमने, जिसको हम नॉर्मली एक्सपेक्टेड वैल्यू कहते हैं, लेकिन क्योंकि हमारा इस वक्त जो कॉन्टेक्स्ट है दैट इज़ investment decision making, therefore this expected value is generally it is called in this context expected profit or expected return from the project. Expected value is calculated, वो हमने आपको बताया था कि किस तरह से calculate करनी है और कि different outcomes हैं and we assign probabilities to those outcomes, we multiply these outcomes and probabilities, take the sum of these and we get the expected return or profit. Now in order to select a project or in order to compare two projects, we have compared the expected value of the two projects, or if the expected value, the project which has a greater expected value, that is selected. If the two projects has identical expected value, in that case what we do is we use either absolute measure of dispersion और relative measure of dispersion, और उसमें फिर हमने standard deviation calculate की थी और इसके बाद coefficient of variation भी आपको बताया था, जिसमें कि हम compare करते हैं standard deviation, the value of standard deviation. Obviously if the spread of the data is greater तो उसकी standard deviation जो है वो ज़्यादा होगी value, so that this indicates that that project is riskier. Next we have considered the possibility that if the probability distribution of a project is normally distributed. For that purpose we have used normal distribution, and we have seen that the probability that the expected value or the expected profit will fall within the interval of plus or minus 1 standard deviation, that is approximately equal to 68%, and the probability that it will fall between the interval plus or minus 2 standard deviation, that is equal to 95%, and the probability that it will fall within plus or minus 3 standard deviation, that is more than 99%. Similarly, we have also shown how to consider a discrete probability distribution and a continuous probability distribution. What we are going to do today is we are going to move ahead now, and today we are going to explain first of all the expected utility, the concept of expected utility, and then we are going to consider again to measure and to remove risk from the our analysis. We will use here valuation model, and this is adjusted valuation model, and for that purpose we'll use two methods, that is adjusted discount rate, and the other method is certainty equivalent approach. Next we will consider some other measures of risk, and those include decision trees and simulation, that is computer simulation. And now we are going to start with the concept of expected utility. In order to understand the concept of expected utility, we need to explain some other terms, and those are the different attitudes of different classes of managers towards risk. And those concepts are, or those terms that we are going to use here frequently are risk aversions, risk neutral, and risk seeker or risk lovers. There is one class of manager which is, and it is assumed that basically most of the managers are risk averse, that is they want to avoid risk. These are called risk averters. Whereas there is another class of managers which are considered to be risk neutral, that is they are neutral towards risk. And yet another class of manager is risk seekers or risk lovers. This does not mean that they simply love risk, because they are just thrilled by risk. Why? Because they know that greater the risk, greater is the reward, or greater is the return that they can expect from one project or more than one projects. To understand this risk aversion, risk neutrality, and risk preference or risk seeking, we have to consider another concept here, because we are assuming here that most of the managers, they are risk averse. This is a crucial assumption, and at the heart of this assumption of risk aversion is the notion of diminishing marginal utility of money. Diminishing marginal utility of money. Now you are quite well aware, or you are quite familiar with the term marginal utility, total utility, diminishing marginal utility, while we have discussed the consumer analysis. And there we have seen that although when a consumer is consuming different successive units of a commodity, its total utility increases, but his marginal utility starts declining after a certain point. So that we say that the marginal utility is diminishing. Similarly, here we are using the same concept. It has been borrowed from the same concept here, and the concept behind the diminishing marginal utility of money, it is the same, but only difference is that here instead of a commodity, the utility of a commodity, we are considering the utility of money. And here, if we are not considering consumers, the economic agents that we are discussing or considering are managers, or they are the entrepreneurs. Now, in order to understand this diminishing marginal utility, let's take an example. Assuming that an individual, he has no money, and we give him 5,000 rupees, obviously he will derive satisfaction or pleasure from this 5,000 rupees, this amount of 5,000 rupees. But we have said that he has no money initially. लेकिन इसके बाद हम उसको और 5,000 देते हैं, और इसके बाद नेक्स्ट हम उसकी एक और इंक्रीमेंट 5,000 की जो है we give this to that person. So we'll see that if we, in case of consumer analysis, we have said that utility is a subjective concept and it cannot be measured. But in order to understand the concept, then we have assumed that there is an imaginary unit which is called a util, so that we can say that, okay, the consumer is getting such and such utils from the consumption of such and such commodity. Here we are going to use the same, that is imaginary units. हम assume करेंगे कि if a person is given 5,000 rupees, how many units of satisfaction or utility he will derive from it. Okay, so we are going to use these imaginary units here. तो अगर उसको 5,000 rupees दिए हैं और इसके बाद next 5,000 rupees दिए हैं, तो उसकी यूटिलिटी जो है वो पहले से कम होती जाएगी. टोटल यूटिलिटी विल बी इंक्रीजिंग, नो डाउट, but the marginal utility, that is the utility from the last 5,000 rupees that he has received, will be diminishing. This is what is meant by the marginal diminishing utility for money. Now, in order to understand this, let's explain this idea or this concept of risk aversion, risk neutrality, and risk preference, and also the diminishing marginal utility of money. We will show you a graph here. In this graph, you will see that we are measuring along the horizontal axis, we are measuring income or wealth of the managers, and along the y-axis, as you can see, we are measuring the total utility. And in this diagram, you can see that there are as many as 3 curves which are labeled as A, B, and C, and their shapes are different. Here you can see that A is, which is the lowest one, A curve A, it is facing downwards, it is concave and it faces downward. Then we have the middle curve which is labeled as B, it is a rising line, and a third curve is labeled as curve C, and this curve is convex or facing upwards. अब सबसे पहले आप जो सबसे नीचे कर्व है, look at that curve which is curve A, and here you can see it is labeled as A curve, and here it is written that diminishing marginal utility of money or risk averse. So this class of manager is reflecting that their marginal utility for money is diminishing and they are risk averters. If we look at the diagram, we can see that on the horizontal axis, income or wealth of the managers is measured, and if he is first, he is at the point, let's say $50,000 uske paas hai, and he gets from this $50,000, that is the return from a project, 6 units of satisfaction. Now, if this amount is doubled, you can see that the total utility will not increase proportionately. That is, the total utility will increase, but it will increase less than the double amount, as we can see in the diagram here, that initially utils are total utility जो उसको मिल रही है यहाँ पे इस point पे है 6, और इसके बाद 100,000 पे है 10. so that we can see the proportionality को अगर हम देखते हैं कि 100% हमने increase किया है उसके return को, but his utility has not increased by 100%, it is less than 100%. So that we can see that the total utility, although it is increasing, but the marginal utility is diminishing. Now look at the second curve. Look at the second curve, which is labeled as B, and here we can see that this is presenting constant marginal utility of money, and the managers are indifferent towards risk. At $50,000, here again at curve B, the total units or utility that he receives from these 50,000 is 6, and when this amount is doubled, his total utility is also doubled. So यहाँ पे proportionality है, जैसे ही उसकी जो return है उसको double किया जाता है, उसकी total utility भी double हो जाती है, which indicates that his marginal utility for money is constant, and therefore this class of manager, they are considered to be risk neutral. They are neutral between these 2 points. Now look at the third case where we have depicted the case for those class of manager which are risk lovers or risk seekers. And this curve is labeled as curve C, and here you can see that it is given that for this class of manager, the marginal utility of money, it is increasing, and he is a risk seeker. तो इस तरह से जब हम इनको कंपेयर करेंगे, यहाँ पे भी हम कोई से 2 पॉइंट्स जो हैं उनको लेके देख सकते हैं कि अगर उसकी जो रिटर्न है, उसके पास एक प्रोजेक्ट का लेट्स से इट इज़ 40,000, और उसके बाद उसको अगर डबल कर दिया जाए लेट्स से 80,000, तो उसकी जो यूटिलिटी है इट विल इंक्रीज मोर देन डबल. सो दैट्स व्हाई वी आर सेइंग दैट हिज मार्जिनल यूटिलिटी फॉर मनी will be increasing. That's how we explain different attitude towards risk, and it is different for different types of managers. For each different individual manager, this risk attitude is different. Either he could be a risk averter or risk neutral or risk lover. लेकिन जैसे मैंने पहले कहा कि हम यहाँ पे अस्यूम कर रहे हैं कि मेजॉरिटी जो है, और इसके रियल वर्ल्ड में भी हम देख सकते हैं कि ज़्यादातर लोग जो हैं वो रिस्क को अवॉइड करना चाहते हैं. सो दैट बेसिकली वी आर सेइंग दैट मोस्ट मेजॉरिटी ऑफ द मैनेजर्स दे आर रिस्क अवर्स. ओके, सो दिस इज आवर बेसिक असम्पशन इन दिस मॉडल ऑफ एक्सपेक्टेड यूटिलिटी. लेकिन बहुत से ऐसे मैनेजर हैं जो रिस्क न्यूट्रल हैं या रिस्क लवर हैं, दैट इज दे आर रिस्क सीकर्स. एंड क्योंकि यहाँ पे ये है कि जैसे जैसे रिस्क बढ़ता है, हमने ये देखा था, तो इसके साथ साथ ही उनका जो रिटर्न है वो भी इंक्रीज हो रहा है. सो दैट दे आर सिंपली थ्रिल्ड बाय दिस फैक्ट दैट एज रिस्क इंक्रीजेज सो इज ऑल्सो द रिटर्न इज ऑल्सो इंक्रीजिंग. दैट इज वाई दे आर विलिंग टू टेक रिस्क फॉर दैट project or for that investment venture. Now, in order to explain this further, we can take a specific example here. Let's assume that a manager is undertaking, he is thinking about introducing a new product. So he is considering whether or not to undertake this project, to introduce a new product. And he has already, the information that he already has is that in case of the success of the project, the probability is 40%, that is equal to 0.4. And the case of failure of the project is it is greater, and that is 60%, so that we can say it is 0.60. And if the project is a success, he will the return that he is expecting from this project is equal to $20,000, and in case of failure, the losses that he will incur are equal to $10,000. This is something, all this information we have presented in the form of a table, and this you can see on screen. Now, we are saying that this manager is considering to launch a new product, and we have said that he knows the probability of success and that of failure. And he also knows what will be the money outcome. That is, it is $20,000 in case of success, and $10,000, and the loss is $10,000 in case of failure. And we are also assuming that the manager in question here, the manager in question, that is the manager we are considering in this example, is a risk averse. So that you can see his total utility curve on screen. In this case, again, since we are measuring total utility, again on horizontal axis, you can see that we are measuring money or the return from the projects, and along vertical axis, we are measuring utility of money. You can see that what is the shape of the curve. From the shape of the curve, you can see that this is his total utility curve, and we can see that since the shape of the curve is concave and it is facing downwards, so from our previous figure that we have explained here, we have seen that this type of a curve is showing the attitude or behavior of the manager as risk averse. That is, the manager is risk averse. He wants to avoid risk. He is not willing to take risk. Okay. So look at the diagram here. You can see starting from the point of origin, if the project is a success, then we can see that he is expecting $20,000, and for this return, the utility is 3 units. In case of failure, he will incur a loss of 10,000, which is shown by minus 10,000 in the diagram. In the negative quadrant, you can see that the amount of disutility or dissatisfaction, in case he fails, is equal to minus 4, which is shown in the negative quadrant of the XY plane. So यहाँ पे हम देख सकते हैं कि $20,000 के लिए total utility is equal to 3 units, while for $10,000 of loss, his disutility is equal to minus 4. What does this show? That his marginal utility for money is diminishing. In this case, we can see that for a risk-averse manager, the pain that he suffers from a lost dollars is greater than the pleasure he derives from a dollar gained. So उसकी जो अगर हम compare करेंगे, the pain and the gain, pain from from suffering a loss and gain from the pleasure that he derives from the success of his venture. तो इस तरह से हम देख सकते हैं कि उसके लिए जो $1 उसने अगर if he loses $1, his pain is greater if we compare it when he gains $1 when he is successful. So that he is a risk-averse manager and his marginal utility for money is diminishing. Now let's see. In table 1, we'll see that the information that we have for this manager. Look at the table on your screen. You can see that here we have the state of nature, that is whether the project will be a success or a failure. Then in the next column we have the probabilities of success, which is 0.4, and of failure, which is 0.6. Next column we have shown monetary outcomes, that is in case of success he will earn or he will expect a return of $20,000. And in case of failure of the project, he will incur a loss of $10,000. That is why we have attached here a negative sign to 10,000. Expected return, as we have seen from our previous lectures, that we multiply the respective probabilities by the outcomes, and the result is that in the last column we have calculated the expected return. That is, we have multiplied probability 0.40 by 20,000 and we get 8,000. Similarly, we multiply the probability of failure, that is 0.60 by minus 10,000, and the result is minus 6,000. And in order to find the expected return, net return from this project, we take the sum of these products and we get a positive value. In this case, it is equal to $2,000. So we can see that although the expected value of the project is positive, this risk-averse manager, he will not undertake this project. While the managers who are risk-neutral or risk-seekers, risk-lovers, they might undertake this project because the expected value is positive. Why the risk-averse manager will not undertake this project? The reason is that the expected utility of this project is negative. And this is what we will show in the second table here on screen, that how to calculate the expected utility. On screen you can see that now we are presenting table 2, and the information that we are using, or the example that we are using, is the same. That is the manager who is trying or who is thinking about launching a new product, and the probability of success is 40% and that of failure is 60%. So this information is the same, and the money outcome is the same. That is, in case of success he will expect $20,000, and in case of a loss or failure he will expect a loss of $10,000. Okay. But now in this table you can see that we have also inserted here the utilities which are corresponding to the success or failure. So first column the probability, second monetary outcomes, and in the third columns we have here presented the associated utilities, and by multiplying column 1 by column 3 we obtain column 4. In column 1 probabilities are given, and in column 3 associated utilities are given. So the expected utility in column 4 is calculated as 1.2 for the success and minus 2.4 for failure. We take the sum of these products and the net result is minus 1.2. And that is how we can see that the expected utility from this project is negative. Therefore, the risk-averse manager will not undertake this project. That is why, since we have seen here in table 1, we have seen that the expected value was positive. Although the expected value is positive, but since the expected utility is negative, therefore a risk-averse manager will not undertake this project. Next, we are going to consider adjusted valuation model. In our very first lecture on managerial economics, we have introduced this concept of valuation model, that is how to calculate the total value of a firm. And for this purpose we have used a formula. In order to refresh you about this formula, you can see this formula on screen, which is given as NPV, that is the net present value. Here, since we are considering different investment projects, so we will say that what is the net present value of a profit. You can see the formula NPV, or net present value, is given as sigma t from 1 to n pi t in the numerator, that is the profit which is going to be discounted for t periods, and r is the appropriate discount rate. So we are going to use this formula, and here in order to measure risk, or in order to modify this formula, we are going to, in this formula we are saying that we are considering the time value of money. Okay, but now we are also inserting the risk element here, that is, in order to face risk, this formula is modified. And for this purpose there are two methods which are used. First is the adjusted discount rate, and the second method is certainty equivalent approach. So these are two approaches that we are going to discuss, and we are going to adjust this model. We are going to make some adjustments in this model in order to take care of the risk which is involved in a project. For that purpose, as far as the first method is concerned, that is the adjusted discount rate. As the name indicates, here we are going to adjust the return rate, and that rate is given in this formula as R in the denominator. So in order to modify this formula, we are going to incorporate risk into the model here, and we can see that this adjusted risk rate, this is a sum of the risk-free discount rate, that is R in this formula, plus the risk premium, that is the premium or the return that the manager is expecting due to risk element. For this purpose, we are going to again here we have drawn a figure for this purpose to explain this concept of adjusted discount rate. And you can see on your screen this diagram. The label here we have given the adjusted value for risk, and you can see that here in this diagram on the horizontal axis we have measured risk, and risk is measured in the form of standard deviation. As in our previous lecture, we have seen that one of the measures that can be used to measure risk is standard deviation, that is the absolute measure of dispersion. So यहाँ पे हमने risk को measure करने के लिए हमने standard deviation को use किया है. On the vertical axis, you can see that we have shown rate of return. So these curves that we have drawn here in this example, they are presenting risk-return trade-off. These curves are also called indifferent curves. We will just explain why they are called indifference curves too. So पहले हम देखते हैं यहाँ पे जो curves जो draw हुए हुए हैं वहाँ पे हम देख सकते हैं that there are three curves. One is a solid curve that is in the middle, and the other two are dashed curves. और यहाँ पे जो सबसे नीचे curve है that is labeled as R double prime, and the curve on the top is labeled as R prime. So let's first of all consider the solid curve, which is labeled as R. As I said earlier that these curves show the risk and return trade-off. Now look at the point A, B, C and D. Okay, first of all point A. At this point, what is the standard deviation? The value of the standard deviation at this point is equal to 0. And the rate of return, that is the expected return or discount rate to यहाँ पे है, that is 10%. So this can be considered as a risk-free rate, that is discount rate, because in this case no risk is involved, since we are saying that standard deviation is equal to 0. And since we are using standard deviation as a measure of risk and the value of standard deviation is 0, therefore we are, in other words, saying that risk is 0 as far as this point is concerned. At this point, for a risk-free project or investment project, the rate of return which is being used here is the discount rate, which is risk-free discount rate, that is 10%. Now we move on to point B on the same curve, and here we can see that if a risk of 0.5 is involved here, that is, now we are saying that the value of standard deviation, or in other words, risk is 0.5. And for this amount of risk, now the manager is expecting a rate of return which is 14%. That is 14% risk free के लिए हमने देखा था project के लिए the discount rate was equal to 10%, but now he is expecting this rate to be 14%, which means that 14 minus 10, 4% is for the risk which is involved, and that is called risk premium. So the difference between the adjusted discount rate and the risk-free discount rate, that is called risk premium. Now next we consider point C. At point C, the risk involved is, that is the value of standard deviation is equal to 1, and at that point the expected return is 20%. So that now the risk premium is 20 minus 10, that is 10%. If the risk is now higher, that is the standard deviation is equal to 1.5, in that case the manager will expect a discount rate, that is the adjusted discount rate, which is equal to 32%. So in this case his risk premium will be 32 minus, that is 32, the adjusted rate, and minus the risk-free rate, which was equal to 10%, so that risk premium will be equal to 22%. Next we are going to consider compare these three curves. And for this purpose, we have selected one point, that is point C for the solid line. And here in this case at point C, you can see that risk involved is 1.0, that is the value of standard deviation is 1.0, and the corresponding adjusted rate is 20%. We are going to compare here R prime and R double prime, so that we are considering or comparing here the points on these curves, that is C prime, C double prime. C prime पे जैसे मैंने पहले कहा कि जब रिस्क जो है वो 1.0 है अब, और तो उसका जो expected discount rate है that is 20% now. Look at the curve R prime, which is labeled as R prime. For the same level of risk, this manager will expect, or he will undertake this project only if the rate of return is 32%. और इसी level of risk पे अगर हम नीचे वाले curve को देखते हैं, that is the bottom curve, which is labeled as R double prime, at the same level of risk, his expected return or discount rate is only 14%. So उसका जो risk premium है वो सिर्फ 4% है, जो दरमियान वाले कर्व है, मिडिल कर्व, उसमें 10% है इसी पॉइंट पर. And for the steeper curve, that is R prime, his risk premium is equal to 32 minus 10, that is 22%. So यहाँ पे हम उनके जो different attitude हैं towards risk, we can see those attitudes here. यहाँ पे हम देख सकते हैं कि जितना ज़्यादा ये जिस कर्व को, ये जो सब कर्व हैं, we are saying that these curves are presenting what they are presenting, a trade-off between risk and return, so that they are called risk-return trade-off curves. The steeper the risk-return trade-off curve is, the more risk-averse the manager is. So यहाँ पे आप देख सकते हैं कि for the same level of risk, that is when sigma or standard deviation is equal to 1.0, at one curve, that is for C double prime, this class of manager only requires a 4% premium. Next जो है C पे आप देख सकते हैं 10% risk premium था, जबकि जो सबसे ज़्यादा रिस्क अवर्स कर्व जो है शो कर रहा है इनका एटीट्यूड, उसमें सी प्राइम पे आप देख सकते हैं द रिस्क प्रीमियम इज इक्वल टू द हाईएस्ट, दैट इज़ 32 माइनस 10, दैट इज़ रिस्क फ्री डिस्काउंट रेट, तो वहाँ पे 22% है. सो इस तरह से हम देख सकते हैं कि जैसे जैसे रिस्क जो है वो इंक्रीज होता है, वैसे वैसे उनका जो डिस्काउंट रेट है, एडजस्टेड डिस्काउंट रेट, वो भी इंक्रीज होता है. बट कितना इंक्रीज होगा, दैट विल डिपेंड ऑन द एटीट्यूड ऑफ द मैनेजर्स टूवर्ड्स रिस्क, दैट इज वेदर दे आर रिस्क लवर्स, विच इज शोन बाय द लोएस्ट, दैट इज द बॉटम कर्व, आर डबल प्राइम, और दे आर रिस्क न्यूट्रल, विच इज शोन हियर द ट्रेड ऑफ. यहाँ पे आप देख सकते हैं कर्व, और जो रिस्क अवर्स मैनेजर हैं, जो सबसे ज़्यादा स्टीप कर्व है ट्रेड ऑफ का, दैट इज लेबल्ड एज आर प्राइम. And I also said that these curves are also called indifference curves. Why? As you can see जब आप देखते हैं solid line में, जहाँ पे हमने different points mark किए हैं A, B, C, so the manager will be indifferent between these 2 points, whether he is on point A, B, or C, or D. The reason is that as risk is increasing, so is the return increasing. तो इसके साथ क्योंकि उसका return जो वो expect कर रहा है इस लेवल ऑफ रिस्क के लिए, वो भी इंक्रीज हो रहा है. सो दैट ही इज इनडिफरेंट बिटवीन दीज 2 पॉइंट्स, दैट इज व्हाई दीज आर आल्सो कॉल्ड इनडिफरेंस कर्व्स. बट दे आर आल्सो कॉल्ड, जैसे मैंने पहले कहा, कि वो ट्रेड ऑफ कर्व्स हैं बिटवीन रिस्क एंड रिटर्न. नाउ लेट्स कंसिडर अ स्पेसिफिक एग्जांपल इन ऑर्डर टू explain this method, assuming that a manager is expecting $45,000 as a net cash flow. जो उसका रिटर्न है उसमें हमारा जो फॉर्मूला है, जो अभी हमने मॉडिफाई किया है, you can see that formula first of all on screen. With the adjusted discount rate, you can see the formula on screen, which is now given as NPV, or net present value is given. It is equal to sigma pi t by 1 plus k whole raised to the power t, where t is from 1 to n. So instead of R, now we are using the symbol K, and this K is showing the adjusted rate of return, adjusted discount rate. और यहाँ पे हम देख सकते हैं कि adjusted discount rate, जैसे मैंने पहले कहा, it is equal to, if we present the risk-free discount rate by the symbol RF and the risk premium by the symbol RP, we can say that K is equal to, as you can see on your screen, that K is equal to the risk adjusted discount rate, K is equal to RF plus RP, where RF is risk free discount rate and RP is the risk premium. So this is how we modify the valuation model, which we have already used in our very first lecture on managerial economics, and there we have said that it is used to consider the time value of money. But at that time we have just considered the time value of money, but now we are also including here risk, that is the element of risk in the long term decision making or investment decision making. तो इस फॉर्मूला को अभी हम यूज़ करते हुए एक एग्जाम्पल जो है वो आपको देते हैं, जिसमें हम देख रहे हैं कि यहाँ पे जो एक्सपेक्टेड प्रॉफिट है इन, एंड द नंबर ऑफ ईयर्स इज़ 5, दैट इज़ फ्रॉम 1 to 5, और जो प्रॉफिट वो एक्सपेक्ट कर रहा है दैट इज़ $45,000, एंड द इनिशियल कॉस्ट ऑफ द प्रोजेक्ट इज़ $100,000. The adjusted discount rate is 20%, so that in the denominator we have 1.20 raised to the power 5 because we are considering it for the period of 5 years. अब आप स्क्रीन पे देख सकते हैं कि 45,000 को हम जो यहाँ पे हमारे पास जो ब्रैकेट्स में जो एक्सप्रेशन है दैट इज़ 1.20 रेज टू द पावर 5. फॉर दिस पर्पस वी नीड टू यूज़ अ स्टैटिस्टिकल टेबल. इसमें हम टेबल यूज़ करेंगे एन्युइटीज़ का, और उस टेबल से जो है हमने ये वैल्यू जो यहाँ पे लिखी है जो आपको ब्रैकेट्स में नज़र आ रही है दैट इज़ 2.996. दिस वैल्यू इज़ obtained फ्रॉम द टेबल. That is, we move across the table until we reach the column 20%, and then we move down the table for 5 periods, for 5 rows, since we are saying that the number of periods or number of years that we are considering is 5 years, so that we reach this value which is equal to 2.9906. ये हमने table से ली है, और इसके बाद we insert this value into our formula, and we simplify this and we get the result which is equal to 34,577. Now assuming that the risk is higher, if risk is higher obviously the discount rate will also be higher. So now in the second case we can see that the net present value can be calculated as 45,000 divided by 1.32 to the power 5 minus 100,000, that is the initial cost of the project. So in this case now we are saying that initially हमने कहा था कि risk free discount rate is 10%, and since risk has increased therefore his risk premium has also increased, and now the adjusted discount rate is equal to 32%. So यहाँ पे 10% risk free है और 22% जो है that is risk premium. Therefore in the denominator we'll have 1.32 to the power 5. Again for this purpose we will use the same table, and now we will move across the table until we reach the column 32%, और फिर इसके बाद हम we will move down the table until for the 5 rows, because the number of periods or number of years that we are using here is equal to 5 years, so that we get this value of 2.3452. and then inserting it into our formula we simplify. Here calculations हम करते हैं and the result is $5,534. So you can see that in both of these cases we can see that the adjusted discount rate in our previous case we have used it as 20%, or second time हमने 32% किया. So we can see that the net present value is in both of these cases is positive, and therefore this project will be undertaken by a risk averse manager. But the difference between these two, you can see that the value of the net present, that is the net present value for the higher risk or the adjusted discount rate which was equal to 32%, for that NPV is smaller, much smaller. तो इस तरह से जितना रिस्क जो है वो ज़्यादा इन्वॉल्व होगा तो इसकी जो NPV है that is the net present value for the manager that will be lower. But in both of these cases so we have compared how what will be the value, what will be the net present value of cash flow when the discount rate is, the adjusted discount rate is 20% and when it is 32%. So next we are going to consider the second method. As I said earlier that for the adjustment of the valuation model we are going to use two methods. One method that we have just now explained, that is the adjusted discount rate method, and the second one is the certainty equivalent approach. Now in case of the first method we have modified the denominator here, but in case of the second method we are going to keep our denominator as it is given in the valuation model. Original valuation model में हमारा formula है, उसमें जो denominator है उसको we are going to keep it, okay? But here we are going to modify our formula by using certainty equivalent coefficients, that is certainty equivalent coefficients, or these are also called certainty equivalent adjustment factors. This certainty equivalent adjustment factor or certainty equal coefficient, it is denoted by the symbol alpha, and alpha or this certainty equivalent coefficient, it is a ratio of the equivalent certain sum and the expected risky sum. In our previous example we have seen that the expected risky sum was equal to 45,000, that is after discounting it for 5 years, he was expecting that he will get what uski jo net present value thi, wo that was equal to $45,000. And we have seen that we have calculated the net present value that was approximately equal to 34,000, 34,000. Okay. Now using this method here, as I said earlier, कि denominator में हम कोई change नहीं करेंगे. This means that we are going to keep the risk-free discount rate. And in the numerator, in order to incorporate risk into the formula, here we are going to make or we are going to modify our numerator. And you can see the formula on screen. Now you can see the modified formula on screen. This is given as we are using the certainty equivalent approach, and NPV in that case will be equal to sigma alpha RT by 1 plus R to the power T, where T is from 1 to N. Certainty equivalent coefficient is the ratio of alpha is equal to equivalent certain sum by expected risky sum, or in symbols this can be expressed as RT asterisk by RT. अब RT जो है that is expected risky sum, and RT asterisk is the equivalent certain sum. That is, this means that this is a ratio, and this is denoted by the symbol alpha. But as far as the numerator and the denominator of this ratio is concerned, the manager he derives the same dollar value, that is the utility that he derives from these two, that is from the numerator and the denominator. The dollar value of these is the same for him. That is why we use the term equivalent. So इसमें जो expected risky sum है और जो कि denominator में है और जो इसमें numerator में है जिसको हम कह रहे हैं equivalent certain sum, there we have to compare these two in order to find alpha. Obviously, when the value of alpha is close to 0 or it is equal to 0, then the project in question is considered to be highly risky. So it will depend on the value of alpha. If on the other hand it is equal to 1, and it is equal to 1 only when the numerator and the denominator are equal. So when it is equal to 1, then it is almost considered to be risk free. इसको भी हम स्क्रीन पे आपको ये दिखाते हैं that how we illustrate different values of alpha. So यहाँ पे आप देख सकते हैं when alpha is less than 1, we can see that this implies risk aversion. And we have said that alpha is less than 1 when the numerator is smaller than denominator. Obviously, जब आपके equivalent certain sum जो है that is smaller than the expected risky sum, only then we can get a value which is less than 1. So in that case, we are saying that the managers are risk aversion. यहाँ पे शो हो रही है, रिफ्लेक्ट कर रहे हैं, और जो मैनेजर हैं वो रिस्क अवर्स हैं, और इसमें जो प्रोजेक्ट है वो इसको जब लेस देन 1 होगा that will be considered a risky project. On the other hand, if alpha is equal to 1, this implies risk indifference, because we are saying that in that case the equivalent certain sum, that is the numerator, and the expected risky sum, they are exactly equal. Therefore, the value of alpha is only in that case equal to 1. If on the other hand the numerator, that is the equivalent certain sum, is greater than the expected risky sum, in that case, only in that case alpha will be greater than 1, and this is considered to be a case which implies risk preference. So taking a numerical example, we are going to use the same example that we have used for the first method, that is adjusted discount rate. तो स्क्रीन पे आप यहाँ पे एग्जाम्पल में देख सकते हैं कि अगर हम ये अस्यूम करें कि ये जो मैनेजर है उसकी जो सर्टेन सम है, इक्वलेंट सम, दैट इज 36,000 in 5 years, and expected risky sum is equal to 45,000, the ratio of alpha will be equal to 0.8. So inserting it into our formula, we get 0.8 multiplied by 45,000 divided by 1.10 to the power 5 minus 100,000, that is the initial cost of the project. So यहाँ पे हमने risk free जो rate था, that is 10%, denominator में हमने वही रखा है. So we have not brought about any change in the denominator. Simply we have inserted, in order to incorporate risk element into the formula, we have inserted the value of alpha in the numerator. That value is equal to 0.8 in this case. The result is, when we simplify this, we get the result which is equal to 36,468. और इसके बाद अगर हम ये assume करें कि risk जो है वो पहले से ज़्यादा हो गया है, so that the value of alpha is lower, that is instead of 0.8 it is 0.62. So you can see on screen that is 0.62 को अगर हम यहाँ पे numerator में रखेंगे तो हमारे पास जो NPV है, that is the net present value, will be much lower as compared to 36,000. Now it is 5,763. So here we can see that when alpha is diminished, that alpha की जो value हो पहले से कम हो जाती है. हमने कहा था कि in that case the risk is higher, so that when risk is higher, the NPV, the net present value of the project, will be lower. So this is how we can use this valuation model. We can adjust this valuation model, and we use these two methods in order to incorporate the risk element into our model. And that's all for today. We'll continue with this topic next time. Thank you. Khuda Hafiz.